All right, guys. So we've learned a lot about teaching Bash as a first language, and I want to regroup and I want to just review some things that we've covered so far. And I want to consider doing it a different way. So we're going to go through the steps that we've gone through so far, but we're going to go through them really quickly and we're going to do them entirely differently. Um, I have been not confident in uh, how you guys are grasping the difference between a function and a subroutine and procedure and all that stuff. And quite honestly, it's premature to talk about that stuff when dealing with Bash. Those concepts are coming from what I used to teach, which was Python as a first language, and it's very easy to do that. So I'm going to repeat for the next 20 minutes or so. I'm going to repeat all the steps that I've done so far with Bash, but we're going to do it without blocks. And I'm going to do it in a different way, which I think will help you understand it better. The first thing is we've already got our place to save our stuff, right? We created a single program. And in fact, let's actually move this. And let's pretend we're going to do it all over again, even though, I'm going to hide it by making it have a dot in front. That's how you hide things, is you put a dot in front of it. Okay. So here we go. The first thing we're going to do, you don't know how to do a thing. Let's make a text file. So we're going to touch a text file. We'll call it hello. And right now it's a hello, right? And you can actually run the program by just running hello. Permission denied. We can't, so we need to make it so we can run it. So chmod plus x dot slash hello. Dot slash means in this directory right here. And you have to do that for safety. So now it's red, and we see that it's runnable, and we do dot slash hello, and we can run it. It doesn't do anything. There's no instructions in it. But this is the part where we get to talk about Bash is just a running interpreter. It's like you can put any instructions in there that you can put here. So let's actually just say hello, echo hello world. There's our first command, and you can see it echoes hello world. Let's put that same command inside of that file. So we'll go into the file, echo hello world. Okay, same exact command. Now let's run it. Dot slash hello world. And there you go. It runs. It's just the same as if we had typed it. We made our own command at that point. Okay. Now I went down a huge tangent when I first did this on what if we tried to do this differently. But that's all you really need to know. That's a program that's running that has instructions in it. All right. So the next step is this. Let's put some more instructions in it. Instead of it having to say hello world, what if we make it so that we wanted to ask what our name was, right? Well, let's make another program. Let's call another program hi. All right. So copy hello to hi. And a lot of you are watching this like, oh my God, he's doing it all wrong. I'm doing it from a very basic level for someone who doesn't know anything about coding. So copy hello to hi. Let's make a new one. All right. So let's change hi. Let's say we wanted to ask a name. So let's say instead of hello world, let's have it say hi Rob. All right. So hi Rob or whatever. Hi you, And so now we can run that dot slash hi and we get hi you. Now, wouldn't it be great if we could add it, if you could add a name to it, right? Well, how would we do that, right? So let's actually go ahead and set a variable. So we're going to set a variable. We're going to say that my name equals, and notice I'm doing it on the shell, okay? So then we say name equals Rob. All right, now we can change hi to use that variable. We can change you to name. And now I can run it dot slash hi and it says, oh, it's blank. What happened with that? It doesn't know it, does it? It doesn't know it. Why doesn't it know it? The reason it doesn't know name is because it doesn't know about it. Now I could do this. I could go into the program and I could write name equals Rob, right? And now I can do hi and it says hi Rob because it knows about it. But how do I want that program to know about the variable that I set? So like we get rid of this and it's still, it'll stop printing it out. So what that means is we need to actually have a variable, but instead of having the variable be just visible to this running program, this running process that we're in, and we talked about processes already, we want it to be visible to that process and every process underneath it. Okay. And it can never be visible to stuff above that. That's insecure. So what we do is we export it. So we're going to export that variable. And we can do it by name. It's already been set. We don't have to do anything else. Now when we run /hi, it will work because we took that variable and we changed its scope. So by default, a variable in bash is only visible to the running process, right? The exact running process, nothing under it, nothing above it by default. But and a variable is kind of like a box that you put stuff in, as you saw. You can put whatever in there. If I change it I can say name equals Doris, and I can say /hi, and now it runs hi Doris, right? Because it's a variable. That means it can change. It varies. It changes. For the record, by the way, you can make read-only variables that don't ever change, but that's not important right now. So right now we just want that value to change. There are all kinds of environment variables that are already on your computer, and if you type env, and you can see them all, right? You can type env pipe to more, and you can see even more of them, right? You can see all of your environment variables doing different things. You have to type q, but these are all variables, and they're in all capitals, and the reason they're in all capitals is because they are environment variables that are meant to be used all over the place. So this is a convention from Unix and Bash that's existed for a long time. That means, so when they make a variable that is meant to be used everywhere, that it's all capitals to really, clarify this is meant to be used everywhere. So if I was going to make my name permanent and make it so it could be used anywhere, I would put it in my bash RC. So let's actually do that. We're going to actually vi etc.bash RC or bash profile, and we're going to go to the end of it. It doesn't matter what yours says. And then we're going to say export name equals, right, Rob. So now every time I run my program, in order to get your bash shell to reset, you do exec bash-l. That will restart bash. Mine has a long startup for lots of reasons, but it brings up a new one. And now I can say echo name, and it's there. Doris is there, but it also has another one. The all caps one is Rob, right? So now we can change /hi to be all caps name. And that kind of signals that I'm expecting this to come from everything. Now, there's no requirement for it to be all capitals, and there are a lot of people that use all capitals for local variables that never leave the file. I think that's a bad idea. I think the idea of all cap variables is very precise. It means that this came from outside of this program. And I don't think that you should set your variable names to be all uppercase in a local file. I think it's a bad practice. A lot of people do that, but I think it's a really bad idea. The only thing that belongs in all capitals is something that's getting reused between multiple commands, right? And so actually, how would we do that? We could actually make hello use the same thing. Hello world, and we could say hello name here. And obviously you see what it's doing there, right? Okay, next. So far we've covered all of the basics about how to make different programs and how to set variables and how those things can change. Here's something cool. You can actually change the environment variable temporarily for a program, right? So I can do this. I can do name equals Doris, and then I can do /hi, and that will change the variable just for that execution of the program. A lot of people don't know that. A lot of people don't know that you can do that. So by doing that, then what we do is we haven't changed the name in the overall. That only changed it for that one process that was running. So like if I do echo name here, you can see that it's still Rob. Okay, so this is actually a really common thing. There are a lot of programs that do this. For example, the Go programming language actually sets the operating system this way when you're doing a Go build, and you can build your binaries for a different operating system than the one you're building on. It's called cross compilation. It's really cool. And this is a way of changing the environments and setting those variables, those environment variables, for that program that's running on that line only. Okay, so even though it has been exported, you're overriding it for that one moment. Okay, so now we've got hello here and we've got hi, and you can see that it's just one command and it's in there. Let's actually expand on that. But before we get too much farther along, you may have noticed that when you open up your program, you don't get any fancy syntax highlighting or anything. And the reason for that is because the program, the computer, your editor, it has no idea what type of programming language that is. And I'm going to show you a couple things that people do to get around that. The first thing they do, I detest. It's absolutely a horrible idea, and I'm going to tell you why right now. But what they do is they'll make the name of the program hello.sh. All right, and now you have a hello. Now when I go to edit my hello.sh, it'll know what kind of thing it is because it has an extension. But it's a bad idea, and let me tell you why. What happens if I want to change this language to Perl? Right? So let's actually do that. And I'm only going to do this to show you, or Python. I'm going to use Perl because I like it. But if you want to use Python or Ruby or any other interpreter language, be my guest. But I'm going to make a point here. So the first time I change the language, right, I'm going to change the language to be Perl. Print hello name. First of all, you can't, there's lots of things you can't do. You got to have quotes around a thing. In Perl, you got to have, this is why people don't like it, but it's got to have a semicolon. All right, that's a string and a character, a form feed or a line return. What am I saying? It's not a form feed. What am I saying? It's not a character return. It's a line thing. It's not a line return either. There's character line feed. That's it. Never mind. So yeah, and these relate to teletype machines. Line feed. Yeah, I just kind of spaced. So now what? So now when I run it, is it going to work? No. Why isn't it going to work? Because it's still trying to run it as bash. It's using the command line interpreter that we're using right now that we're interacting with every command, right? And so when we put those commands from the command line, we put them into a file. That's all well and good as long as the file is still bash. But in this case, it's not. It's a different thing. So we need to give a hint to the bash interpreter to say, hey, no, don't use yourself here. We want you to go use another program. And so this is where shebang comes in, and we're going to change this to hello. We're going to put a shebang in. So the bash interpreter and pretty much any language shell command line interpreter will look at the first two characters of the file, and if it's a shebang line, it will use whatever's on that line to run the program. So in this case, we're going to say user bin Perl. All right. And shell check only supports, this is interesting. Look, scripts. It doesn't support Perl. Why is shell check freaking out? Do you know why? I bet you can guess. Why is shell check freaking out? Do you see down here? Oops. Why down here? Yeah, look down here. Look down in the corner down here. What kind of program does it think it is? It thinks it's shell. Why? Why does it think it's shell? Do you know why I hate suffixes now? No, it's modded. It's executable. That's why I hate suffixes. I was not allowed to change the language of the program because of the suffix. If I wanted to do this, I'd have to do this, which a lot of people do, and I hate, because now, who cares what the language is? That's completely non-Unix. That's a completely non-Unix way to do things, my friends. Let me just, this is one of my biggest pet peeves of all. People who use suffixes unnecessarily, because you are permanently forcing dependencies on a specific implementation of the language. So that command can no longer be rewritten in Go, C, Rust, or anything. And everything that you have that depends on that program has now got a hard-coded, broken dependency on a specific shell. Do you have any idea? Go on GitHub and look at all the people that do this. Okay, I'm going to calm down now. But I'm telling you, don't do that. And you know why now. You just saw why. The thing you should have done instead is just kept the name to be hello. And then it's perfectly happy to change the language. Who cares? You want to rewrite it in Ruby? Be my guest. It'll be the same thing. You want to compile it as Go? Let's do that. All right. Let's move hello to hello, old. Let's write a quick Go program. All right. So let's write VI hello. I'm just going to, just as a point of illustration. All right. So Go, there it is. We say, change this to hello. All right. Now we're going to compile it. Go builds hello dot go. And we build that right here. And now we have a hello program. Now look at this. File hello. All right. It's now an executable ARM program. Exact same command, does the same thing, but this is now a binary. I rest my case. Okay, if you continue to put suffixes on your files, that's on you, because now you know why it's a stupid ass idea. All right, I'm moving on. I am so tired of that. Okay, so move hello. Let's get rid of hello go. Move hello dash old to hello, and you can do what you want, but that includes being, So anyway, vi hello. And here we go. So we're back to Perl, and it's like, I don't know what you want to do here. It's like, what are you even trying to do? Use once possible typo. Main name, use only once. What's going on here? Shell check can't speak Perl. Wait a second. Does shell check know Perl? No. Huh. Oh, that's coming from Perl Critique. Never mind. Yeah, this is, if you're going to do Perl coding, I have a shell formatter for this too. Only use once possible typo. Oh, right. Oh, that's not a thing. In Perl, you have to do this. Just in case you guys are wondering. Yeah, I know this is not about Perl, but that's what's got happened there. All right, same idea though. So this idea about using environment variables, that every single language uses that. Okay, on every single operating system. So knowing about those variables, that already exist on the system. Yes, you can code them in your programs, and we're going to do that next. But what I wanted to show you is you can set those variables right away interactively. All right, so let's pick up where we left off. We've done our hello program. Hello, we made it into Perl. Let's actually change it back to bash. So, but I'm going to do one other thing. We're going to do user bin env bash, which is insecure, but if you're just doing it for yourself, it's okay. This will prevent you from having to change this line on every single computer you might ever want to run this on. I could do this. I could say, so you can do this too, which bash, and bang, bang, 2 exclamation points, and run that through bash, and that will give you the exact path to bash. Let's talk about that. So that is where bash lives. So we need to have a conversation now, and we have to talk about pathing. And I know this is normally premature in a programming sort of conversation, but it's really important that we talk about it early rather than later. Just remove the extension we need to play is a horrible idea. I don't agree with that at all. Why? Tell me why. Why? It's a horrible idea. Don't do it. I'm telling you not to do it. If you can do it yourself, obviously you can do whatever you want. In case you're wondering, yes, you can wrap quotes around your strings if you want to, and you probably should. So let's go ahead and do that. Let's see. It may clash with a future reserved word. So there we go. And we're going to run that /hello world. All right. Including Windows method of using file extensions. Yeah, well, that's not the Unix way. If you're going to use Windows file extensions, then yeah. So, here you go. You got opt homebrew bin bash, and that's where bash lives. That's where the bash executable program lives. We talked about what interpreters are and all of that. So bash is a binary program that runs right in memory of the computer, and it interprets the commands to follow into signals and into system calls and stuff that are talking directly to the computer for you. That's why it's called an interpreter. So bash is a compiled language, and echo hello world is a statement that gets parsed and then put into those instructions that get sent to the computer. As long as you're on the same computer, this is safer. It's always safer to say, this is where my bash is, use this one. But as you can tell, if I'm on a Linux machine, it doesn't have homebrew on it, right? It would have user bin bash, And no matter how much you may want everything to live in the same place, very frequently it doesn't. So if you're using something that doesn't require a high level of security and you're using your own machine for this, then you can get away with another trick, usermin env bash, and that will find bash wherever it is and run it and then do the same thing. So that means that exact code, in the GitHub repo, if you download that to your Linux machine, your Windows WSL2 or whatever, it will still work because it will find bash wherever it is as long as it's on the system. In production, you would never want to do that. In production, you would always want to specify the exact path to bash for lots of performance and security reasons. So that's the thing. The insecure argument against the use of that is the same reason we used to have to define the path up front, because you can inject something that's named bash in the path ahead of the actual program, and it will run in place of the other thing. So it allows you to have path injection attacks on a system, which is one level less secure than not having that. If you are explicitly defining the version of bash that's being used, you are never subject to that attack. So that's the reason. And if you don't know what that means, listen up, because we're now going to talk about how a path gets resolved. If they don't have to tamper with your path, they have to tamper with stuff that you have in your path. So let's say a user gets, let's talk about what path is first. Okay. So the path, my friends, is all of the different places that your programs can live that don't have to have the explicit path. In the case of we've been doing /hi. This is an explicit, albeit local path. Dot means here in this directory right here, and slash means this directory right here, right? // would mean the directory above it, right? Now I could have done this. I could have said, where are we? I could have said, I don't want to, but I could do this, right? If I wanted to do the explicit path, I could say, let's do it, say /hi, and this is the same thing, right? Because for security reasons that I just mentioned, anything that is not in your path cannot be run without being precisely fully pathed out. And that includes relative paths called /local. That's why you have to do /local. By the way, never, ever, ever add dot to your path, which we're about to do. It is one of the biggest beginner mistakes ever made. Don't do it. It's so insecure. It's so dangerous. So you always want to force people to type // to run things in the current directory. And if you don't want that, then when it's ready, put it someplace that it can be run in one of these places. Well, how do you set what those places are? Okay, so the way that those places get set is in your bash RC, or you can already look at the one that's already there. I have a program called Path. This is a very simple program that is, it's a very simple program that we'll get into later. This is actually a really good example of something called parameter expansion. And what it does is it takes the path environment variable. We already talked about those. It takes the path environment variable, which is this big, long, ugly thing, and it replaces all the colons with a line return. That's all it does. It's one line, nice and pretty, and it just helps you see the ones that come first are the ones that resolve first. So I talked earlier, somebody was questioning the use of usermin env to do a path attack. If I put the bash binary, if I am a malicious user on the system and I have access to any of these directories at all in any way, and I can make a binary that runs there that's named bash, that program will win. It will win because it's not explicitly defined. That's why it's insecure. Because if something else can grab that thing, and they might even know, a normal path injection attack would be, what you would do in your injection attack is you would say, okay, I'm going to make a program named sh, zsh, bash, all the common things that people use, Python 3, Python, anything that somebody would think that they're using. And if you have access to their, to their path ahead of them, then that thing will run instead of the other thing. And you can have it run and still call the other thing. So you can have it do all kinds of side effects on, because they're running it with their permissions. So this is a very, very legitimate hacker target. It's one of the greatest ways to escalate permissions is by looking, you search for the system for everybody that's using userbin env on the system, and then you see which directories these people are using in their path, which you can also identify, and then you put stuff in there that's Trojaned in the path, and then they run it. When next time they log in, they run these things with their escalated permissions, perhaps an administrator, and then this is why administrators won't run anything with userbin env, period, because they know better. Because if they go on there as root or sudo or something, and they actually get Trojan like this, they can actually get you as an administrator to run something with elevated permissions that you normally would not, that they would not run. And then you can create a setuid binary that has full permissions as root, because you just got escalated root access. That's how it happens. And in fact, it's such a dangerous thing in a multi-user system that in the old days, we had to explicitly set the path variable in our program. In this particular case, we would do this. We would say path equals blank. So we would do that. Export path equals blank. And we would, in the old days, it was so important in a multi-user. We have less concern for this because there's not as many multi-user systems. But in a multi-user system, if you're writing a system script, you would do this. You would do, user bin, usually user bin path, user bin bash, and you would have export path, and you would say nothing can run here. And the thing that's so great about this is that required file not found. Whoops. Oh, wait, because it can't find bash, right? So we could say, wait, is there not a user? Oh, wait, it's bin bash. Whoopsie. Sorry, guys. It's a good thing. All right, so this is now extremely secure. In the old days, path equals a blank or something. In the old days, by doing this, if you try to do an ls command, it will fail, because it's like, I have no idea where ls is. And so by setting an explicit path, and this is still a thing. If you look at the dash scripts in Debian and some of those scripts right there, some of them do this, because it is so important that some of this stuff gets run as root. And it is so critically important that this stuff explicitly say, I only want to enable stuff at these locations. And so it will explicitly say it. And by setting the path like this, you automatically secure your script from any kind of path injection attack. Now, you're a beginner. You may not have cared about all of that, but I'm telling you right now that this is the way to do it. And if you want to be a little more serious, if you're writing a system script, then you should do this. But if you're writing a bunch of stuff for yourself, which, somebody was giving me crap about this because I changed and softened my position on this. If I'm writing a bunch of stuff in my dot files and it's just going to run and it's only going to be me on my laptop and only my laptop, then the convenience of having userbin env, which was invented by Ruby people, by the way, that was the first people that I know of who used it. Perl people did it a little bit, but they didn't really start using it until the Ruby people started. So you can use it in bash, and then that'll run bash as it's found in your path, and run inside a script. It will not affect any of the commands running inside of the script. All it will do is force you to explicitly add to the path all the things that are being used. Okay, by doing that, you put that thing. The fact is, if you're a security person, you care about this, and I'm preparing future black, white, gray hat hackers. You just need to know about the path, okay? You need to know that it exists, that it's a thing. Here's two reasons you need to know it. Number one, you want to own people. You want to own somebody with root access. Say, hey, dude, I need some help over here, right? And then you go ahead and put that, and you do path injection. You can take over. You can do a path injection. You can take over, man. I guarantee if I wanted to social engineer somebody into root access on a system, I would say I'd get an admin, okay? I'd get an admin, I'd say, come over here, I need some help. And then I would get them to sudo something for me, and I would inject a Trojan bash into the path that they didn't even know about. They would run it, they would give me setuid root access to the system, and then I would delete it. And they would know there'd be no evidence of it, because there's no There's no history of what files have been deleted or on the system. You want to get root access? That's how you do it. That's how you get root access from an admin. You want a social engineer. And you have to know what you're doing, but people have done it. People have done it. And you know what's funny is, I mean, I'm not telling you to do this, but you'd be surprised. You'd be surprised how stupid admins are. Some of the admins are. They will not even, they don't even know about this. And so now you do. You know about it. And more importantly, you know what path is. Okay? You know what path is. Important setting. Okay, so the reason I'm going off on this and my rethinking of this whole entire way I teach you Bash is because I don't want you to walk away from this thinking this is a good practice to do in production. Okay? It's not. The only reason this is even a thing is because Bash is in 5 different places depending on what computer you're on, and I don't want to have to screw with it for my files, for my dot files. That's the only reason to even do it. We run fake login on terminals and wait for people to log in. Hell yeah, Epic. Yeah. You know exactly what I'm talking about. Right? Right? So, okay, now you guys know. Okay? And I'm not making Netflix engineers here. I'm making secure systems operations and sysds who are really, really crazy good at what they do, and they're doing it right. They're doing it securely. I'm not, helping you like bust out a bunch of stuff and learn what the terminal is by learning NeoVim. True story. Somebody learned NeoVim by learned what the first time they ever used the terminal was inside of NeoVim. That's not what I'm targeting you for. I'm targeting you for systems operations. Okay, so here we go. We've got these 2 programs. They're running now. You know what the path is. Okay, so how do we play around with the path? Well, one of the things we could do is we could say, if it's in my lab, I want to make it runnable, right? So how do we do that? Well, we have to edit this file. There's a file on your system. It's called bashrc right now. You can put it in .profile or .bash profile or any of these other places. But right now, the first thing we're going to do, we want to stop having to like type / every time. So because we trust this particular directory. So we're going to go add it. And we're going to go add to the end of it. I got lots of other stuff in here, but let's say, so the way to normally do this, and this, you just have to trust me on this and make sure you get this right. If you screw this up, you want to see me screw it up? Do you guys want to see me screw it up? If everybody who's watching right now I guarantee you let me show you what happens when you screw it up. Okay. If you accidentally put the wrong path in there, you won't be able to do anything. So watch. Make sure I get an extra terminal here. All right. So, okay, watch this. Okay. So I'm going to export path equals blank like this, right? I can't do anything. Oh my gosh. Everybody's done this. A couple people were saying they've done this in their lifetime, right? Everybody's like, oh, I need to add a new thing to my path. And they accidentally take over their path. And they're like, oh no, what have I done? And it's even worse when you do it in your bashrc, because now you can't edit your bashrc because you don't have Vim. It can't find ls. It can't find anything. Your path is empty. It has nothing. There's no commands you can do at all. It can't find anything. You just made your shell really secure. You can't do anything. So, I think you can do built-ins. Echo, let's say echo hello. Yeah. Okay, you can do it. The host name thing is because my PWD, my line keeps asking for it. It's so secure I can't do anything. All right, so how could I do that? Right, well, in this particular case, I just start up a new shell. But if you really had to do it, you have to use the full path. All right, you can use the absolute path, yes. So in the emergency event that you do this to your bashrc and you need to edit your bashrc to fix it, the way to do that is to provide the full path to the thing. And I don't even think which works. No, it doesn't. God. So you need to do I don't even know where Vim is. I think it's and you can't ls to know where it is. Is it bin Vim? Is it bin Vim? Nope. Okay, is user bin Vim? Dropping frames. Yeah, I did drop frames there for a second, I noticed. User bin vim. Yes. Show me all the things. Vim. Okay, there we go. Okay. So if you had to, you could do user bin vim and you could, open up your bash.rc file and fix it, right? In my case, I don't really have to do this. I just have to exit because I didn't change it, right? But just be really careful with this because as soon as you do this, you will do this wrong. Usually what people will do is they'll do something like this. They'll do path colon, right? And I'm going to show you a trick because I don't want to write the whole place that I am. I'm really lazy. So I'm going to write pwd right here. And I'm going to do bang bang, 2 exclamation points, bash. And that will send the line to the bash thing and replace it with its output. Okay. And we're going to cover bash completion. Yeah. So you see what it did there? I didn't want to type it in my program. There's other ways to do that. I could have done something like this. I could do, I think, what is it? R. God, I don't even know the commands, but some people do R and then they do bang. I think pwd. Yeah, that does the same thing. I like writing code that writes code. So I'll like write a little bit of code. I'll put a pwd here and then I'll transform it really quickly with bang bang bash enter. You can make that a macro and then I join it up. Okay. Now this is still wrong though. It's called a filter. It's called a Vim filter. And what it does is it sends the current line to the command that you indicate and then replaces that line or whatever you selected with the output. That's what it does. It's a way to do math and all kinds of stuff. So like if you want to do scale equals 2, 2 divided by 3, you can send that to BC. That also works. You can do read. Yeah, you can do R. PWD works too. People have all kinds of things. But this, I don't want to type. Sometimes I want multiple lines, right? And I want to send all of those lines. So here I go, bang, bang. And I'm going to send this to BC and it'll replace it with its output, right? There's nothing wrong with doing the read if you want to do that. But I'm like this, right? Sometimes I might want to have a few lines in there and I'll write a little program and it'll be 2 or 3 lines long. And instead of doing exclamation point, I'll do exclamation point, write curly bracket, and then it will send the block and replace the whole block with the output. So I regularly will write code, like right here and then just replace the code with its own output by sending it to an interpreter of some kind. And you can send it to all kinds of interpreters. There's all kinds of things, right? So, and that's how I prefer to do comments. I just do comments that way because it's faster than visual mode. These H title lines are all the same thing. So I say hello and I do bang bang H title and it will replace it with the title. I could have like H title. I think I can put, I don't know. That one's not. The point is that I have like an ecosystem of filter commands and I just keep using them that way. So anyway, there's a big problem here that I have wrong. What have I got wrong here, guys? Most of the people who kill themselves when it comes to like path, like we just did, this is what they do. What's wrong? What's wrong with it? Yeah, it's missing $1. And I guarantee you there's at least 2 or 3 or 10 people watching right now that have done this. They've forgotten to put the $sign. And if you forget to put the $sign, you just got rid of all the directories that have ls and pwd and bin and everything. So make sure you don't forget the $sign. All right. What we're doing is we're just adding more stuff onto the end here. And in order to get your new stuff to be visible, here's the moment of truth, right? I'm a little scared to do this live because if I screwed it up, it's going to be very embarrassing. You do exec bash -l. And what that does is it replaces your currently running shell command with a new one that's also a login shell but has the new settings. And that's all that does, right? So now when I type my fancy path command, you can see that the one that I added to the end here has been added to the end. Okay. Now this is really great because now watch. When I do which hello, what does which do? Put it in your notes, people. What does which do? Which hello will tell you which hello program would have been added. Uh, Try to add it to the end of path. Then you protect system commands. Absolutely. Yep. Okay. The only time you wouldn't want to do that, by the way, is, of course, the first thing wins, right? So the only time, there are some times that you might want to shadow an existing command. So, I mean, it depends on the command. There's a couple commands that I don't find a lot of utility with, and that they have existed forever. And like open, I think, is one of them. And another trick is you can put a script that's going to call an actual binary someplace else. I do this with my links command. I have a links program that I want to use that runs the same binary links, but it actually, does all of its setup and then runs it. So sometimes you might want to put a program that takes over another program up higher in the list, but almost, the safer thing is to add it to the end of your list. And that way, if nothing else exists, then it will work. That's important too, because every single script that you run is going to use your path. Everything does by default. That's why it's so important to explicitly, define your path in highly secure shell scripts, because you don't want them to get path injected. So there you go. That's what we're going on. So the thing that's cool about this now is that I can type hello and hi, and I can be anywhere. I could be in my home directory and it works. I could be in the root directory and I can type hi and it works, because it just finds it. It knows where to find it. So let me do hello, and we see that, oh, hey, look at that. It's running a different one. Why is it running that one instead? Because like I said, it looks like I have a hello program that is higher than the other one. Interesting, right? So can you see it? Let's see which hi is it using. Look at that. You found it first? Yeah. Okay. So what it did, so hello is, I have two hellos. I didn't know that. It's good. It's a good example. So then you can see that here's the other thing. Even when I'm in what am I doing? Lab sample, right? So even when I'm in here and the program is right in front of me, it still doesn't run that program. Do you see what I'm saying with security? Right? So hopefully that's starting to click. Because like right here, I can, unless I do /hello, right, which we know is the right hello, it's going to run the other hello. So I do which hello, right? But hi is the same one. So even though I'm typing hello, it's not running the hello that's right in front of me. It's running the hello that resolves in the path. And that's what which is about. Okay, so put that in your notes. I'll use the thing. All right, so let's keep going. We're almost burned up another hour here. So we've got our hi and our hello, which we already did before. And the first time I taught this a couple days ago, I went and we went right down the if then else conditions and stuff like that. But I want to do this a different way. Does export take the var values out of the global list and send to processes? Is that why it's called export? No, what export does is it exports it into the namespaces, the environmental namespaces of everything under it. It exports it into any child processes whatsoever, whether it's binary or a shell script or anything. So, and you guys remember process trees, right? You remember what processes are about, right? So we have all of these running processes on the system. SPS tree, grep. I mean, this is a pretty big tree here. Yeah. But so this is all the processes that are running on the system. This is a huge process tree. And all of the things that are running. If you do top, you can see all the running processes, right? So all a process is a running program, and you can send signals to them, which is what the whole Control C thing is about. If you send an interrupt signal to a process, it stops, it interrupts it, and it can trap it and all that thing. So we'll get into that later. That's a Linux, Unix thing. Actually, it's a systems thing. It's more of that than it is anything else. It's not you kind of need to know it if you're going to be, an operations person, but it's strictly speaking, it's not a part of computer science as much as it is a part of how operating systems work. So anyway, we've got hello and hi. Let's look at them. We got our hello and we got our hi. And okay, we actually have a problem right here because our hello is that other hello is getting in the way. So I'm actually going to go remove it, and I'll show you a trick for this. Be very careful with the trick I'm about to show you. So I'm going to delete that program. I'm not there. I'm nowhere near there, but I don't want to go there. I'm too lazy. So I want to remove that file, even though I'm not in that directory. So I'm going to do rm which, and I did a backtick there. The backtick is kind of, you don't know about it yet, but it's the same as that. I'm going to do that, and I'm going to say remove which hello. And now I just, without any confirmation, blew that thing away. And so now when I do which hello, it'll resolve to the right one. And now when I run hello, it finds the right one. Now, it's still hashed to the other one though. So when this happens, you have to rehash. What is it? Hash dot whatever. You can either exec bash -l, which is what I usually do, but there's a command to rehash. What it does is bash keeps track of all the last locations of files, and we delete it so it can find it faster. And we deleted it. And there's a command for that, but I can't remember it. How do I rehash in bash after removing a binary from path? If you take something out of your path, for efficiency reason, bash does this. You have to rehash it. There it is. Is it #r? Remove a single command from the hash. Okay, just #r. Okay, so #r. And now we say which hello. Yeah, there it is. Okay, so now when we type hello, it'll find it, and we're good to go. I always have to look it up. I knew it was hashed, but I couldn't remember what this thing was. So that's more than I would normally cover with a beginner, but we were only on hello and hi. You know what variables are. You know what commands are. You know how to make them executable. You know how to safely set up your path. Now let's move on to the next thing. Okay, what if I want to make a program that also can be used by another program? And this gets kind of interesting. Okay, so let's do this. So what is a date? So there's the date program, right? And this is a significant departure from how I used to teach programming in Python and JavaScript and stuff, because I am teaching it from a shell perspective. And the shell is all about combining commands. That's what it's for, and it's really good at. So we have this program, this command that sends the date, and you can actually make the date really pretty. In fact, I think, yeah, I see now. So here's this. I'm kind of giving away the answer here, but so you see what you can do with the date. You can put all these fancy things and make it nice and pretty. But the point is that you can actually use this someplace else. So what we want to add to our hi program is we want to add the date. It's like we want to say something like, it's a beautiful Monday. How about that? So let's first of all look at the date command, and like, how could we just get the date to show the day? It's like, so we can say date -h, man dates to see what it is. I don't know what it is. It's probably going to be, or we could go to my AI. Yeah, I don't even care. Watch this. How do I isolate my date to just the long English weekday? I could go reading through the man page, or I could just ask my AI. They're the same. I have to look it up no matter what. So I don't want to hear it. Either way, I have to look it up. It's not cheating. Either way, I would be reading the man page. It's just so much that my AI is much faster. I mean, I don't want to go, look at how far I'd have to read through this thing. I just got the answer much faster than that. Okay. So anyway, there's no shame in doing that. And frankly, you're going to need to do that, or you're going to lose a job. So here we go. How do I use this now? Right? How do I use this? How do I use this really awesome thing? So I'm going to put, let's say, is it hi or hello? Let's do hi. Hi's got name in there. Let's put a shebang in the line in here because we know what it is now. So let's put a shebang. User bin env bash. And we'll reload it. You don't have to do that to get it to do the thing, but it's a good idea to do that. So we could say, hi, so-and-so. Nice. And then we're going to say date, right? We want the date. So let's say what the date is right here. Date plus a, isn't it? How about that? 2u or something. We don't want a question yet. So, the debate about clean code, I don't want to talk about it. We're not talking about clean code. It's a bunch of bullshit. Just like anything else from Uncle Bob. All right, so here we go. We're going to say /hi, and it says, okay, this is hi, Rob. I'll go back here and say, hey, nice to you, right? So hi. Now, I didn't have to do that. I could just do hi now. Hey, Rob, nice Monday to you. All right. So do you see what it did? It took another program, ran the program, took the output of the program, and put it into a variable that it's used in the other program. That's a very, very Unix-y thing to do. You make a bunch of little programs that do what you want, and then you compose them together in different ways. That is the Unix way. That is the Unix way of doing things. And there's no need for plugins or anything because you can just write other executables in whatever language you want, and they are modularly able to be included into one another, right? So like if I wanted to, I could say, we can make another program here. You see how that's date? I really like the fact that that is the, that it's the weekday, you know, and I had a hard time remembering it. So what if I did this? What if I made another program here, right? So we call it weekday, and we schmod it, schmod plus x, weekday. And I call these, I mean, you can keep them small. There's no rule against it. And then we can put that in there, right? Hell, I can, let's make it bash. In this case, I know it's going to always use user bin. Actually, in this case, I can just use bin sh because I don't need bash, right? I don't need bash. There's nothing about this command that needs to be bash at all. So I can just make it plain old POSIX shell. And that's simpler, it's faster to run, it's safer. So now when I run weekday, I get the weekday. All right? It's pretty cool, right? So the thing that's great about that is now I can change my other program. Instead of it having it be date, I can change it to be weekday. And now I can say hi, and it does it. Okay? And it's really funny. You want to see something cool? Yeah, let me show you something about weekday. You could say plus in 2 weeks, in half a week. I think you can do that. You can actually do some weird stuff. Yeah, no, it didn't work. Anyway. There's some, you can actually use date to calculate, offsets and to come up with it. You can use natural language. It's pretty cool. So anyway, that's like the date command, and it's just a one-liner. Now you're like, well, God, why would you make it like that? Then you can have to use it everywhere, right? And by the way, why would you make it a script as opposed to, maybe in your bash RC function? So there's another way to do this would be to put it in your bash RC instead. And then you can always use it, but there's a very serious disadvantage to doing this. So if you do it this way, we're going to do it. So if we say weekday, okay, you don't know about functions yet, but so let's learn about how to do it. How do I do the same exact thing in here? So there's the command, but how do I make it so that it's into a command without really being a command? Well, enter functions. Okay, these are, I call them subroutines because they're more accurately called that. But so now you can do this. You could say weekday. And now you have to do the thing. I mean, there's many ways to do this, but this is the standard way, right? And so now I have a weekday function. Now, the thing you have to do, remember that whole thing about exporting? So you can't use this function anywhere else but here unless you do an export. So traditionally what we'll do is we'll do and export -f weekday. This is a bash only thing. This doesn't work in Z shell or POSIX shell. But now that function is built into the shell. Now, there are advantages to having a shell function and there are disadvantages. The most serious disadvantage is that I can't use this function in a Go program because the Go program can't see this in this function. The only thing that can use the function is another shell program. period. And also, I mean, it can be, you could actually export it and it will work if the calling shell, the parent shell of the Go program is, also bash. But if it's not, let's say it's on PowerShell or something, it won't work, right? So there's arguments against having a function. In my case, the only time to have a function inside of your bash RC is when you really want it to make a difference. And I have one called clone in here that actually changes what directory you're running in. And that's one of the only reasons you should ever have a shell, a bash RC function, in my opinion, because the criteria should be, is it going to change my state? And state is your current working directory. You cannot write a program that will change your working directory in a script. You can't do it, because the changing into that directory is a property of the child process that's running, and it's now in there. But as soon as that process dies and goes away, all of the state of the caller comes back. And so you pop back up to you don't really pop back up. You never were down below. And then you come back up, right? And there's no way, it's impossible for you to change and have it keep you in another directory unless that was executed in the exact running shell that you're in right now. This is a really common error beginners make all the time. And so they think that they can do the thing like that. You can't. So if you want to, the bottom line is this: if you want to change anything about your currently running shell, including your current working directory, it has to be in a function or an alias. All right. And it can't be in a separate script. However, if you want to write code that can be rewritten in Go, or rewritten as a multi-call binary, or rewritten in Perl, or rewritten in C, then you should start, even if it's only one line, you should start out with, these tiny executable scripts or whatever, because those can be replaced and they will work anywhere. They will work anywhere. They'll work in anything that ever calls it. So, and then that gives you a lot of functionality later on. This is going to become much more relevant later when we talk about using the Bonsai command tree branch builder, which actually allows you to make a single binary that's got hundreds of little tiny programs in them that are all what's called a multi-call binary, so that it travels as a single binary, even though they all look like they're independent commands. We're going to get to that later. So right now what we have is the ability to run weekday. Weekday is a thing. And by the way, that's where the word type comes in. So when you want to see, so the only thing which shows you, the only thing which shows you is if it's in your path or not, right? Which I don't know. So foo. So, it doesn't show you a thing. But so how about this? Which clone? There's no such thing as clone. Like, I know there's a clone command. So you use type for that. Type will show you that the clone is a function. Type will also show you hello is a thing and where it's at. So that's the difference between which and type. There's one other thing. It's called command-v, which is also specifically for executables when you want to know the exact path. This will not work if it's on a function. So it'll give you which is, kind of wrong. So a lot of people say to use that. I don't. I use which almost universally. You're learning so many things. I hope you're learning things. Good. So the next thing here is we've got a couple of minutes left on this one. Let's catch back up. We're almost in 1 hour. We've caught back up to what we were doing before. In the earlier days, I put all of these different things into functions, and I did the whole language thing, right? The whole grading thing. So, but we concluded the last hour by putting a random color into a function. But let's do the same thing, but this time let's use let's keep him into the Unix way. One tiny program that does something really well and integrates with other things. That is literally the Unix philosophy. I'm going to ask her, what is the Unix philosophy? Right? It's not a bunch of functions. The Unix philosophy is a set of guiding principles by Ken Thompson, Dennis Ritchie, and Doug McCullough. Ken Thompson, by the way, is one of the primary contributors to the Go programming language, along with Rob Pike. Do one thing well. Write programs that do one thing well rather than large monolithic programs. A lot of people would say that in 2024, this still is doable. Git is what's called a monolith There are lots of monoliths in 2024, but their first verb, their first action is kind of in compliance with us, right? So you could argue pretty strongly that in modern times, now that we have memory and everything, that this do one thing well has come to include like sort of an umbrella program like Git or GitHub command line, or anything you can make with Bonsai, so that you have do one thing well, but the first verb is like the do one thing well. Compose programs. Make programs that when you add them together in all the ways that we just did, you get a larger program, and then you focus on one thing that works really well, even if it's only one line. And then another thing, use text as a universal interface. That's another common thing. Make sure that they work together. And this is very much the Unix philosophy. So this is why so many things are in text because of this. So we already did it. We got, weekday. I mean, weekday is like nice and simple. It's like one little command, but we don't have to go look it up every time. Now we can use that as if it were, reusable anywhere because it's in our path. So let's keep going with this idea. What if we were to make one that would show us the color? So I have a program called term colors that just dumps out the term colors, right? Well, what if we could make a command that would actually send a random color command, right? What if we did that? So we already wrote the code for this. So let's write it again. Only this time, let's write it as a separate command instead of as a function. So we're going to make a new program. So touch rand color. Name it wherever you want. Dashes in names is totally fine. Underscores in names is usually not fine. Dashes are regularly used all over the place. You can just do rand color if you want. I kind of like the dash in this one. I enter into evidence every single SSH command that's ever been made. So, whatever. So rand, let's do rand color. I have a lot of rands. I use rand as a prefix for lots of different things. So let's make one. So touch rand color, schmucks. What is schmucks? Type schmucks. You guys want a schmucks? Do you want a schmucks? Let's add a schmucks. Okay, so let's add an alias really quick. .bash rc. I'm going to show you how to add it, and I already have one, but let's show you how to add it. Bash rc. We're going to add a schmucks alias. Schmucks equals schmod plus x. Okay, save that. Boom, you got your alias. That's how you get your alias from then on. You go exec bash-l, restart your shell, and then you've got it. So now you can, instead of having to type that because it's so hard to type, right? I mean, I type it a lot. And I have another command. It's called new x, which automatically makes a new command in the right place. And then it puts the user bin env bash at the beginning and schmucks it, and then opens up my editor and starts editing on it. Yeah. You can write your own. It's just the beginning, my friends. Just the beginning. So you're going to have a lot of fun stuff. This is ridiculously addicting, by the way. Doing all this fun stuff. All right, so there's no user bin env. Wouldn't it be nice if that was automatically created? Yeah. Yeah. Now I could make a macros, a million things you could do here, right? But I'm not. I'm just going to do user bin env bash. Now let me show you how. Kokus knows how addicting this is. So, okay. So you see how my file type down at the bottom here says none. All right. So there are a couple ways to get this to reload the file type, but let me show you one that you can just do. So you do colon, right? And then you do ft. Is it set ft? Ft stands for file type, and then you change it. Say file type equals bash. There's probably a faster way to do that, but that's one of the ways I know. Is that slower or faster than just closing it and reopening it? You decide. But now it knows what I'm writing, right? So let's go ahead and write this. What is our bash command going to do? It's going to print a random color. So let's start by dumping the colors in here, and you don't have them, so you're going to have to go look them up. But you see how I have POSIX, and then I also have bash, right? So we're going to stick with the bash ones. And we actually don't need all of the different colors. In fact, we could do a macro here, actually. Yeah. Should we attempt a macro? I don't put underscores in my bash ever. I put dashes, unless it's a variable. If it's a variable, then I'll put underscore. Yeah. Anything that's running, I use dashes. That's pretty conventional. So I was going to do a macro here. I'm not a macro master. I don't use them very much. But this could be a really solid macro opportunity. So let's go ahead and start a macro with, what is it? No, it's Q, right? It's Q, I think. I don't even do macros. I am not a master of macros because macros don't work everywhere. That's why I don't know them very well. How do I start a macro? Someone help me. Is it Q or is it, at is how you repeat the macro. You know what? I don't need to do that. I don't need to do it. You know why? Because I'm going to use Perl instead. So there. I'm going to do my way. Yep. I'm going to do Perl-ne. Actually, we could almost do this just with a straight up command without Perl even. Yep. We could say, I want to replace everything up until the equal sign. If I want to delete it, it's easy. That's easy. If delete it is easy. So, yeah. Anyway, I'm not fast at this stuff. I tend to think in terms of filters. So I'm trying to go out of my comfort zone and do stuff in here that's doing this thing. So if we do this, if we say s dot and we say everything up to the equal sign. Oops. See, you can't do it because it's not a regular expression. This is one of my biggest annoyances. This is why I hate basic regular expressions. You can't use a plus there. Watch. S, comma, dot, which means any character. And then I say plus, it doesn't do it. Plus is a Perl thing. Okay, I have to escape a plus because I'm using extended regular expressions. I know I'm going to do capture groups next. But why \+? Perl doesn't do that. This is why I don't like using the regular expressions that are not Perl. You know what I mean? I don't even know what that is. So, yeah. This works generally speaking, and then you put an equal sign, right? And then, okay, so that's kind of okay, but now I'm going to do capture group, and I'm going to put the capture group around here. And then I say, okay, so now it's got a capture group, and I want to dump the capture group at the end. So then I want to say, I want to put a hashtag in there. Where's my hashtag? Okay, here we go. And then space, and then the capture group 1, comma, G. No, just 1. Enter. Nope, it didn't do it. Capture groups didn't work. Pattern not found. Because stupid regexes. Yeah, I hate regexes in this language. They suck. They're so much worse than Perl. This is why I use Perl for everything. All right, so there you go. All right, so that sort of did it, but I had to escape everything. I hated that. I hate that. Okay, we put the escape sequence in the wrong place. So let's do that. Let's say, okay, so we need to have it, we have to have it replace it with, well, we have to have this other part too, right? So we have to have the second capture part. God, I hate these regular expressions. These are so bad. They're so freaking ugly. All right, so then we're going to replace it with the second capture group. Okay. And then as a thing, and then we're going to put the \1, and that shows me what I want. Now, the thing that is nice about NeoVim, and this is a NeoVim thing, is that NeoVim shows you the transformation while you're doing it. So you get kind of a sense of what's happening. And, you know, that's all well and good, right? So that did what I wanted. And I didn't have to do a macro. So I still think that's better. But you could do the same thing with a Perl command line filter. Let me show you what I mean by that. if I was going to do the same thing with a Perl command line filter, I would do that. I would do a thing and I'd send it to Perl -ne, and then I would say, let's see. So we could either, if we put a P in there, then, okay, so we wrap it up. All right. So we're going to do a replacement and we say, I'm going to try this. And it's not going to show me while I'm doing it because it's a filter. So I'm going to do actual regexes that, the God intended, which is Perl. Perl are the world's best regular expressions. And I can do plus here. Actually, this one you can say, I think you could do that. And that will say, don't get too greedy. Because plus is going to include the colon unless it's too greedy. So I have to tell it not to be greedy. Either that or I could just say this. I could say not equal sign plus. Which is, they're kind of both the same. So that would be a thing. And then over here we say dot plus equals. And so then we say, so that's how we do that. And then we just print. Oh, actually we could use an F on here too. So you could say we just want to print, was it $? I'm wondering if we'd have to do. I'm trying to think here. I've been wanting to get better. Yeah, I think. Yeah, I'm trying to remember. Is it It's not F. What is it? Is it underscore? God, I've lost my Perl so much. I wrote it so much. But that's a better regular expression. A macro is not easier. No, it's not. I mean, a macro is easier if you want. Okay, so let's do a macro. For those who say they want to do a macro. All right, so let's do macros. Let's try a macro. How do I start a macro? I know. People do crazy macros all the time. The problem with macros is that you only have so many of them. So don't get it. As soon as you start saving multiple macros, it's probably time to put it into the script. But I agree. I need to get better with macros. So I can't remember how to start a macro though. It's like, is it QQ? It's QQ for macro. Okay. So now we go. So now it's recording everything I do. So let's do this. Let's say I want to, okay. So I want to delete up to, the equal sign DT equals enter. And then I'm going to paste it onto the end. So Control A and then escape and P. And then, go back to the, actually, let me undo that. And then we can say, I'm sorry, there. And now we can do, P. Okay. And then we can get rid of that thing at the beginning. So we can go to the beginning and then X, oops, and then X, and then, and now that does the transformation. And now we can save the macro, which is Q again, right? Isn't it Q again? Is it Q? I think it's Q. Yeah, I think you have to do like Q and then what the letter is after that. And Q by default is the macro. So you go down here and then to get the macro, you do, was it A? I can't remember. Is it AQ or it's AQ, right? I can't remember. I think it's Q, whatever. Back at the beginning of the next line so you can chain them. Right. So, right. Or you could do this. You could say Q, wait. Which one is the, I can't remember which one it is. I don't do macros. I'm telling you, I don't. I never have. I never needed them. And my Perl's gotten rusty because I've gotten so fast with just regular stuff. So I'm a big spammer of things. Is it add Q? Add Q, because Q is the default, right? So add Q. Yeah, it didn't quite do that one. Yeah, this is my problem with macros. I do think it's worth getting good with them, but I'm clearly not. I'm gonna try it. I'm gonna try it again. All right, so QQ. Let's say, all right, let's say delete / equals, enter, uh, and then X, and then capital A, space, and then escape, and then P. Oops. And I did the last restore thing. Yeah. So X counts as a delete thing. I thought maybe it didn't. Yeah, I hate macros, man. I hate them. I always have hated them. But that doesn't mean I'm a master at it or whatever. I like Perl transformations. That's what I'm used to doing. And I'm a big filters fan. Because once you do a macro, then it's gone forever. So I don't like that. Yeah, there's like a good macro. Let's try that. So QQ, QQ, what are you doing? 0, right? Okay, so that goes to the beginning of the line. And then we delete up to, you're doing delete the word, but that's not going to get rid of the, yeah. I mean, the word is cool. I mean, that deletes one word, but then you have to add it to the end. What are you doing with the what are you doing with the double quotes? I don't know if you need it or not. You definitely don't need it as a beginner, which I know we're totally off on this video. Zero secure 0 instead of QQ. Oh. Okay. Yeah, I don't know if I like that. Yeah. So I don't know what your I don't know what your double quote is for. But that's not a thing for me. So anyway, so QQ0, let's say QQ0. So I would normally, I thought maybe you were going to the 0 position. Yeah, so we're gonna do DIW. It will delete the word. That's fine. But then we need to add it to the end. So capital A to go to the end, and then space pound sign P. Wait, escape P. Okay, and then we need to go to the beginning again. So that's 0, and then delete, and then I guess we could go down to the bottom of the next line. So we go down to the bottom of the next line, and then Q again. All right. So now I can do, what is it, at 0? At 0? Yeah. At 0. And then after you do the first one, then you can just do dot to repeat the last macro. So dot, whoops, apparently not. Can you not do that? So add does the last macro, right? Add does the last macro. Add at. Okay, so there we go. We're on the last macro. I tell it to delete X. Double quote tells it to delete X into the underscore register. If you want to put it into a register and then paste it into the black hole register. Does that work in only Vim? Again, people, one of the reasons I don't do macros is because I'm pretty sure they're the kind of macros that people are using right here are not BI compatible. That's why I never learned them, because I'm pretty sure they're a Vimism, and I'm almost positive that's why I didn't learn them. I actually had to ask Chloe about this. Are Vim macros compatible with VI? And there's a lot of reasons, like DIW, DAP, CIW, all these things that I never learned in Vim because I learned VI. And I use them all the time now. So I'm always open to things. Short answer, basic Vim macros might work in traditional VI, but anything that relies on Vim special features for commands, including buffers, by the way, like the black hole, will not work. Your further recorded macro states from classic VI commands less likely to be compatible. You know what is compatible? Filters. They work no matter what, everywhere. So that's why I tend to be a filter for preference. Okay. Anyway, that was a big rabbit hole. Sorry, but if you want to do that, go ahead. I don't want to paste equals, which is why I black told it. Okay, gotcha. All right, so let's do this. How do we put that into a function now? So we're going to put this into an array, which you already did. So we'll put it in. We actually don't need a function here, but we could put one if we wanted, right? So if you wanted to, you could just declare all these, but to tell you the truth, we really don't need to, but we do need to put them into a list. Okay, so let's say colors equals, and we're putting them into a list, otherwise known as an array. I'm using the word list because I like the Python terms for these things, dictionary and list, even though, you know, there's problems with it. Colors appears unused. Okay, so now we're going to do the random. You already know about this, right? We already did this. Echo $random. $random is guaranteed to have a number between 0 and 2 to the 17th minus 1. No, 2 to the 16th minus 1. Is that right? 32, whatever. Anyway, it's random. But if you echo it, if you echo random and you want to do some math on it, then you can actually take the modulus of it. If you only have 8 things, and it'll give you the 8. But in order to do math, you need to do this, and that does math on the thing. Integer math, by the way. There's no such thing as decimal math in both POSIX shell and bash. It does exist in K shell, but it's a huge mistake. Don't do it. Because people will expect it to not, and you should be using BC for that. So we're going to do a whole thing on math, but for right now, when we do for loops, we're going to do a whole thing on math. So for right now, for the math, we're going to have this. We're going to say, we got random, modulus 8, which again divides it by 8, and so whatever the remainder is what's left over, which gives us a number between 0 and 7 inclusively. So now we have that thing. So echo, we can just run it. So /rand color is 2 1. I mean, hell, we could even make a program that is just a one-liner that's a random number between 1 and 8, right? We could do that, but we don't want that. So we want to actually look it up. So we're going to say colors, and we're going to look up that index between 0 and 8 and 0 and 7 inclusively. And okay, we can't use echo. We have to use printf. The reason for that is because echo does not do escapes. So, and printf does not like things that are, I don't, this is really stupid. I really wish it would do that. You could have done just echo -e, but that's not compatible across the board. Neither is random, quite frankly. So let's stick with echo on this case. Echo -e will do the escape for you, and it'll shut up because there's no random on a system that doesn't have echo -e. So we might as well use echo -e. Printf always does the escapes. So they're both equivalent. Now you get a random color. It's like, well, it's not doing anything, Mr. Rob. It actually is. So yeah. And what it's doing is it's taking, a thing. So, and it's printing it. So we can say echo rand color something, and then it will do it. It'll return it every different color, a different random color every time. What if we made it so it took in a string or something? We want to have it take the thing in, right? So let's do that. So instead of having it just do this, let's have it read in the string. So let's say echo the dollar. We want to take the things that came in, and there's a couple of ways of doing this. But let's just use $1 because that'll be the first word that was passed in. Okay. And then we can say echo, and we can actually do a reset. So let's put reset as its own thing. Reset equals this. Oops. A reset is its own thing, and so it equals reset here. And obviously, we can put all that on a single line if we want. That's also fine. I think we need -e on this one. Oh, whoops. Reset. I think we might have to have a -e in there. Yeah. So now we can do this. We can do echo something. Wait. Rand color something. And it's whatever we send it, it does it. Now, It's kind of lame though, right? Because it's putting this extra line there. Do we really want that? Probably not. So watch this stream later after I get back. Okay, so let's go back here and we're gonna say, and let's actually go back to a printf instead because we got lots of stuff we're putting there. So let's do that. Let's just say printf, kind of easier to keep track of, and we'll say, you know, the beginning part S and the ending part S, and then we have the middle part S. So then we can have the color, and then we can have you know, $1, which is the argument that was the single word that was passed in, and then we have the reset. So, and I didn't have to make these variables. I could have made them direct, right? So now when we run it, we run something. Now you see how it didn't put a line return in there? And that's fine, right? So let's actually go ahead and add a line return. A line return is a \n. I mean, it's not a line return, it's a line feed, strictly speaking, but it's effectively a line return. I did it wrong. What did I do wrong? Oh, stupid. I put it in the colors thing and not the... All right, so there we go. All right. And watch this. You can just do watch. Oh, damn, it didn't colorize it. That's too bad. You see the numbers changing though? See how it's 35 and 32 and whatever? That's interesting. It's like it's not escaping the colors when you run watch. Watch just runs the thing at a standard loop. It's like every n seconds. It's like putting a for loop. You know, it's exactly the same thing as that, but we're going to do that later. All right, so that's enough for today. You know, you want to do the rand color as a separate program. Hello. And then whatever you have in there will be a color. Now, what if you wanted to say hello there? What will it do? It's only going to print out that. Okay, so how do we have it group the whole thing together? The first thing we do is we can put quotes around the whole thing. Now it sees the whole thing, okay? And that's $1. Now, I'm going to show you a trick, though, really quick. And that is something called the dollar. Instead of having this, we're going to do splat. And what that does is that takes all of the arguments together and jams them into each other. It combines them all together. So if you do that, then you can say this. Instead of saying hello there, it'll still work, but you can also do hello there. And you go, and you know, it'll, you know, it's a little bit more forgiving. You know, it's not perfect, but it is a way to get rid of having to type quotes, and who wants to type quotes when you're doing stuff like this? So, you know, that's the way to do it. So now you can say you got weekday, you got random color there. You could say, we could go back to hello. We could add it there. We can say hello world. We could say, we can go back to hi, and you can change. You could say, you can make the name automatically a color. Watch. Let's make the name a color. All right. So let's say rand color name. Now that's going to blow up because why? Because we don't want to have shell injection. So we put quotes around it. And now we do this. We say, now we can say, what is it? Hi. Hi, Rob. Nice to meet you. Hi. It's like a different color every time. Okay. And we're kind of learning how to compose together a bunch of commands. We have already learned how to do functions, but sometimes it's better to just make them into individual commands. And that's why I wanted to redo this video. It is an hour and a half long. We did go down quite the rabbit hole with macros. I apologize for that. I am not good with Vim to the degree that other people are, but my skills with Vim are more universal. They usually apply to VI and different things that you're going to be on as opposed to only the NeoVim system you're working on today. So I should probably learn macros better, honestly. But you know what? Everybody else should learn filters better because they don't know them. And they sure as hell shouldn't be learning stupid, essential, basic, regular expressions, which are, they're just horrible. They're horrible, and they're not that same way and using everything else. So that's the thing. I'm going to stop this video right now. I am going to make another video, and we're going to return, and we're going to do for loops on Bash. I really want to get to the point where Bash is done. So everything in your Bash RC is done, and I'm kind of motivated to finish that today while I wait for my wife to come home. So I'm going to end that video now and we'll start another one in just a second.